Good evening, and welcome to the Albright Scholar for July 2019. My name is John Pankratz. I teach history at Albright, and each month it's my privilege to welcome BCTV viewers and residents of Greater Reading to take a glimpse inside our learning community up here on North 13th Street, to talk about the work being done by students and teachers, and to think about its impact on all of us. Well, we're in the middle of the summer, and at Albright that means Acre Research, the Albright Creative Research Experience, and it's participated in by teams of students and teachers doing some really path-breaking studies in all sorts of fields. I have a list here of 16 different projects, and I won't list them all now, but over the next 3 months, we'll have a chance to hear in a bit more detail what people are doing. And they range from the field of psychology and psychobiology to sociology, to fashion design, to literature in multiple languages. Really a wonderful range in the sciences, the humanities, and the social sciences and the arts. So for a long time now, the Acre program has been a wonderful one. Today we have one of the Acre teams, participants in some organic chemistry research. Julie Schrey is a rising junior, a biology biotech major at Albright, and Professor Christian Hammond is no stranger to the show, professor of chemistry and biochemistry. Welcome back, Chris. Welcome, Julie.
Thank you.
It's great to have you here. I always ask Acre participants, what's this about spending your summer in the lab when you could be, I don't know, taking a vacation? That's what members of the general public imagine students doing in July and August.
Well, I think, being a sophomore and, becoming a rising junior, it's really important to get that research experience. Mm-hmm. And, it's something that I feel passionate about, just research in general. And I think, I can go to the beach on the weekends if I want to, So, I'm very happy to be in a lab and very grateful for the opportunity.
Yeah, it's a nice opportunity. These, we should say these are competitive grants. There's a whole committee that decides. And these days, many more people apply for these than receive the granting. But you get a stipend and you get housing for the summer. The professor gets a stipend as well. So it's a sort of a win-win.
Yeah.
Yeah. From the professor's point of view, Chris, what's the attraction of this kind of work? Close one-on-one work with students.
Close one-on-one work with students is what's known as a high-impact practice. So we know that the outcomes are strongly positive. They give students authentic credentials. They often get to not only do their research and write some kind of large summative work at the end, but also they may get to present their work locally or nationally at a conference, which is also a valuable experience in every field, and in chemistry, you can't do it without it.
Right.
In our case, I want to go back to the comment about going to the beach. One of the other advantages to doing summer research is last Wednesday, all of the chemistry students and the faculty, so a ragtag fugitive fleet, went up to Shells on Route 61.
Oh, there we go.
Yeah, or North 5th Street Highway, and played miniature golf. So it turns out
27 holes.
All 27 holes. Yeah. And not only is Julie a competent researcher, but she's also quite a crack putter.
So. That's really good to know.
Yeah, secret talent.
Okay, so I'm forewarned. So if I challenge her, I think the golf program airs next on BCTV. So
there we go.
Maybe I should
we can keep you around and talk more about that. Let me hear a little bit about the genesis of this, the project that you're doing. I know that sometimes students will hear an idea in class or in their own reading and say, oh, I really want to know more about that. Sometimes a professor will have a project in mind or maybe an ongoing research agenda and will say, oh, this is just the right student to take on this research. How did it work in your case?
I think it was kind of a combination of both in a way.
Okay.
So I remember it was the first semester of organic chemistry, and we were talking about stereochemistry and how, I believe you used Carvone as the example.
Yeah, Carvone.
So how one conformation of the molecule will taste like mint, and then another conformation will taste like dill. And so I just thought that was kind of cool. And then, going through organic chemistry, I found that I just really enjoyed it. And then I know you kind of had more of the genesis of the project itself.
Yeah.
But we were both kind of in search of going for research. So yeah, but I don't know if you want to talk about the genesis of
The
it.
project is about 5 years old. It was born of necessity. We needed a way to organize our thinking about these systems. And the first student who saw it was actually Trevor Hamlin, class of 2010, who was finishing...
Dr. Trevor Hamlin now,
Dr.
yes.
Dr. Professor
Yeah.
Trevor Hamlin. And he saw it as a graduate student when we worked together for a short time on his senior thesis, which has since been published. And then Jordan Zare, class of 2017, 16. Anyway, around there.
Yeah.
And he actually was the first student to work on it and made great strides. And then Julie, who was in my organic chemistry class, was looking for a project, had diligently applied to a wide range of programs. The dilemma with being a sophomore is that you're competing with juniors and seniors who have more experience. And so when she talked to me about the Carvone example, which is a real household example, I mean, most household cabinets have dill or caraway or spearmint or
Ours
these
certainly does.
Yeah. It seemed like the right student and the right time and the right project, and Julie's really taken the ball and run with that.
Right, we're talking about sesquiterpenes, which sounds complicated, and in the molecular model here, it's going to look very complicated. But we all know what these are. These are naturally occurring hydrocarbons that are aromatic and have flavors and tastes and different kinds of combustion and everything else going on with them.
Yeah.
Some pretty familiar organic compounds. Yeah.
Well, you want to talk
For
about
example.
your fruit collection?
Yeah, this is not just the decoration.
They are beautiful. But
Yeah,
Yes.
this is a great arrangement.
So in the rind of each fruit, it actually contains terpenes, terpene molecules, excuse me. And so that's what actually gives it its fragrance. And so terpenes are just 10 carbon molecules, but they react similarly to the 15 carbon sesquiterpene molecules that we're working with. So you mentioned squeezing them, and
Yeah, they don't do this in high schools anymore, apparently, but if you squeeze the rind of an orange, children, if you're doing this at home, make sure your parents are around. You squeeze the rind of the orange into, say, a lit candle, and the terpenes will be ejected, and you get a little bit of a flame. But really, like if you have a cocktail, or you're baking a bread or something like that, or you're just wringing out the fruit, those oils that you smell are all this natural product.
Right.
And they're not just to smell nice, right? They protect the fruit. You're an orange. You can't run away from predators,
Not easily.
right? So the oils actually protect the skin from insects that want to eat it.
Yeah.
So
Yeah. So it's a whole ecological relationship as well. And those things that we call essential oils and aromatherapy, all of that depends on this chemistry
Yep.
as well. Okay, so what are you doing? How many sesquiterpenes are there?
known? I don't know.
thousands.
Yeah, there's thousands. Yeah.
And you're going to do a little bit of a census or database of all of them?
Yes, so we are creating a database, and so currently there are databases that exist that will tell you the connectivity of the atoms within the molecule, so it'll tell you the order in which they're arranged.
Okay.
But so we're actually looking at the structural conformation of the molecules.
And
So
you're saying conformation?
yeah, so
The way they're actually shaped.
yeah, so whether maybe a hydrogen is like this way rather than that way, and you can measure their angles, and that helps differentiate them further than just connectivity.
Right. They have the same number of carbon atoms, the same number of
Yes.
hydrogen atoms, but the directions in which these are attached change the nature of the compound.
Yep.
Oh, wow.
And you can have different ring closures, which then also further complicate everything, which also shows the need for a database that tells you conformation rather than just connectivity.
Oh, wow. nature is endlessly inventive, isn't it?
Yes, it is.
How wonderful.
It's really a very simple starting material. So in Julie's model here, I'll
Yes.
stand it up and put it up in front of the fruit. You can see the repeating colors. You have the red and white, red and white, red and white, right? So if you just look at it literally as if it were a belt, right?
Okay.
If you bring the belt this way in towards the audience, right, you would get one connectivity. If you bring the belt backward, you can get the same connectivity, but those two are mirror images,
Right.
right?
Right.
So now one could smell like dill, one could smell like mint, very different outcomes. So you need to know not just the connectivity, but whether or not they're mirror images and so on. And we wanted a fast and easy way to do that. And Julie's database will help us to do that.
Wow. So you're setting up the database on a Excel program, or?
Yep.
Uh-huh.
Yep. Yep. So we are actually currently we're going through all of just scientific literature, and we're pulling out
Okay.
structures from there and entering them in and pulling their angles out and putting them on an Excel file.
Okay.
And
these are the precise angles.
yes.
Yeah.
And yeah, and then from there, hopefully it will become a searchable database that people can use electronically. Because the big issue in scientific literature today is they think that they found or discovered a new molecule, when in reality it's just a different conformation of one that already exists. Or you have the, vice versa, you have people think that they found a repeated molecule, but it's actually a new one. And
It's actually new. Okay.
Yes.
This sounds very useful.
Yes,
Right. But it sounds like an enormous amount of legwork as well.
it is.
So you're reading, what, hundreds, thousands of
A lot.
individual research articles?
Yeah. We've gone through quite a few this summer. I wish we had the figure to show them.
Yeah. How many individual molecules do you think you've looked at so far?
Oh.
Because one paper can have anywhere from 5 molecules
Right,
to
because it's
To
150.
looking at
hundreds.
different, different
Yeah.
iterations. And, yeah.
Probably, I want to say close to 500, because one paper alone had about 250.
The 2014
Yeah,
paper.
the 2014.
Wow.
So I've gone through quite a bit, but yeah.
Another challenge here, John, is the change in the way data is stored. So a lot of this data was originally stored on paper,
Right.
and then it was stored electronically as, say, a PDF or a
Of
Microsoft
the
Word
article
document.
or something like that. But-
Right. And the field is slowly moving into electronic databasing, where what Julie is doing in part, and other students who have worked on this project, is they're extracting what is on paper in some variety and making it electronically accessible. And in that case, you can not just look at a set of 3-dimensional coordinates on a page, but you're actually looking at a molecular structure on a program designed to do that.
And then also side by side with hundreds of other molecular structures.
Right, and that will be eventually part of the database. So it's not just the structures, but it's the source files in an accessible format. So,
Oh, that's perfect. That's going to be a real aid to research.
right.
Yeah.
I'm sure as a historian, you wish all your archive boxes were in
We're
alphabetical
neatly lined up. Oh, goodness, yeah. And they never are. They never are. And they're covered in dust, too. So have you developed a real taste for the great scientific article, or are you simply in there looking for the structure?
It was actually interesting. So typically, the traditional way of going through an article is, you read it, and a lot of people just kind of ignore.
Or maybe read the abstract and see what the problem is that
Yep.
it's being addressed. Yeah.
And a lot of people tend to ignore the figures, and it's kind of interesting because this project, you don't take that approach. You go and you look at the figures first, kind of see what's going on, and you use the text itself as a guide for you to try to understand maybe, where one carbon has moved or stuff like that. So it's very interesting. It's very different reading scientific articles for this purpose rather than I have in the past.
Right.
So-
Now you're a biology major rather than a biochemistry major, but this is all grounded in organisms, isn't it?
Yes.
Yeah, because plants and everything that lives makes these little hydrocarbons,
Yeah.
and they all have specific functions in a biological sense and
Yep.
ecological sense as well.
And their conformations will also alter how like an enzyme will react with it as well. So
Okay, so at the molecular level as well.
yeah.
Oh, how fascinating! How fascinating. Where does this fit in to your own sort of student and research career?
I don't know what it was, but I just really liked organic chemistry, and I just kind of took a liking to this kind of stuff. And I think just having a background in organic chemistry, especially as something as thorough as this kind of project, really enlightens you.
Yeah.
And it makes it a lot easier to look at molecules, whether you're looking at molecules used in more biochemical reactions. So it's very useful.
At some point, all biology becomes chemistry, right? You get small enough, and then you start talking about the compounds, and yeah, that's it.
Right.
Yeah.
If you get too small, it becomes physics.
Right, exactly, yeah. And then after that, it's philosophy.
Yeah.
Yeah. Is this something that you think you'll continue working on, or will you drift off into an aspect of this with this as a sort of feather in your cap, or?
I'm not sure. I don't know. I mean, I would like to continue, but I'm not sure. Yeah.
So we'll see.
We'll see, yeah.
Talented students have many options.
They really do. And as you were rehearsing some of the names, I thought of the really dozens of students that I've had on the show doing acre research. And I keep track of many of them as they go into their future and look at their MDs and their PhDs and their professional accomplishments. But it's literally a jump starter. In some part, it's finding those really talented and really hungry students. But then also it's just the kind of work that this is. Just makes you, get you ready for those next steps.
Yeah.
Yeah. Now I know that each week, all the students doing acres get together and have lunch, and one of you, or maybe two, gives a brief presentation on the work. Have those been enjoyable?
They have, and I think, you know, especially going to a small school like Albright, you kind of see, like, even though, yeah, I'm a biology major, I can still, you know, enjoy chemistry, and I can still go and I can enjoy a presentation on storytelling or colors and how they affect politics, and it's really it's an enjoyable experience.
Right.
Yeah, it's really nice.
No, it's a chance to mutually appreciate all the creativity and
Yeah.
thoughtfulness that we have at this place.
Yeah.
No, it's a really positive thing. I know that Albright's proud of it. I know that President Fetro is participating, both as a fellow researcher with a couple students, and then also as, well, not a fashion model, but as the customer for some very original fashion design as well. So, and we might talk about that on a future episode of the show. Well, this has been wonderfully enjoyable, encouraging, and kind of inspiring. We'll hope that some of our viewers at home have some research aspirations, and will think of Albright and think of the acre as a possible element in their future as well. Good. Chris, thank you. Julie?
Thank you, John.
It's been great to have you. Thank you as well. We'll see you again in the month of August, where we'll report on some more acre research on the next edition of the Albright Scholar. Good night.